Hello friends, let us take one more example of multiple integration where the region is mentioned. So here we have taken this example, double integration over region R where xy dx dy where R is bounded by two parabolas. Okay, one parabola is y square equal to minus x and other parabola is x square equal to y. So first of all, we will draw a rough picture of this region. So here let us draw this region. Okay, so we have taken our plane x-axis and y-axis, origin over here. Okay, now see that x square equal to y is a parabola like this. Okay, so let me draw that parabola. This is x square equal to y. Okay, or y equal to x square, and the parabola y square equal to minus x is on this side. Okay, that is symmetric about the x-axis. Fine. So this kind of picture we have of two parabolas. Now the area that is bounded by the two parabolas is this area. Okay. So one point of this area is bounded at this 0, and this point we need to find out. So let us call this point as A. Okay. So what is this A is? So to find out the coordinates of A, we need to solve these two equations. So this is equation y square equal to minus x, and this is x square equal to y. So both these equations we need to solve. Okay. So what I'll do is I'll substitute this equation over here. So we will get what we can do is let us square both sides. So y raised to 4 is equal to x square, right? And x square is y. So I say y raised to 4 is equal to y. Okay, see here I have squared, so we got this one, and then for x square I have substituted as y. So taken on this side, y raised to 4 minus y equal to 0. Okay, so if I take y common, it is y equal to 0 or y equal to 1, right? Okay, so if I put y equal to 1 in one of these equations, right? So if I take y equal to 1, x will be plus or minus 1. So I am getting this point as minus 1 comma 1. Okay, so see that here we have squared first of all this equation, then x square has substituted as y, take on this side, factorize. Okay, this is y into y cube minus 1. So we'll get y equal to 0 or y equal to 1. Substitute in one of the equation, you'll get the x coordinate, and it is equal to minus 1. So this is minus 1 comma 1 point, this point. Okay, right? So now we will need to integrate. So we need to fix out what are the integration limits of these two integrations. Okay, now that requires to decide how you will traverse this. So this now you can traverse in both ways. One, you can keep your pen parallel to x-axis and you can traverse like this, or you can keep your pen parallel to y-axis and you can traverse like this. So now this is up to you. So there are two ways now to get the integration. Okay, so what we will do is here we'll take parallel to x-axis. Okay, so we will first of all integrate with respect to x-axis and then with respect to y-axis. Okay, so what I'll do is I'll keep my pen like this. Now see that when I'm keeping my pen like this, it is intersect to the left side, okay, to the parabola x square equal to y. Okay, so I can say that x is equal to, so I say that I is equal to c. If I keep my pen like this, it is intersecting on this left hand side to x equal to root y, right? Because x square equal to y, so x is equal to root y. And on the right hand side, it is intersecting y square is equal to minus x, so x is equal to minus of y square. See, x equal to root y, x equal to minus y square. how this is obtained? Okay, see, I have decided to take the integration to traverse the area like this. This I haven't decided. So once you decide like this, what you do is you find out the limits in terms of x equal to something on the left hand side, that will be your lower limit, and x equal to this curve, that will be your upper limit. Okay, and we have obtained that. Then if I put that my pen like this one, then I am traversing the area from 0 to 1 like this on y-axis. Okay, so on y-axis the limit will be 0 to 1, right? And then xy, dx, dy. See, now this is decided. This order is decided. The inner integration limit is with respect to x, outer limit is with respect to y. Okay, see that this problem, same problem, we can solve in other way. You can put first, that means inner limit with respect to y and then with respect to x. That also you can do, no issues. Okay, you'll get the same answer. Okay. So fine, now let us solve this. So this is equal to 0 to 1. Okay, see that now here this y is acting as a constant, so I can put it outside the integration limit and I say root y to minus y square x dx and then dy. Okay, and this is a simple integration, so this is 0 to 1 y into x square by 2 from root y to minus y square dy. Okay, and therefore it is equal to 0 to 1 y, so this 1 by 2 I will take outside, and this will be what, y raised to 4 minus y dy. Okay, so if we open this further, so I is equal to, now let me open this, so this is half times integral 0 to 1, this is y raised to 5 minus y square dy. Okay, and therefore it is half into, now this is y raised to 6 by 6 minus y cube by 3 from 0 to 1. So it is half into 1 by 6 minus 1 by 3. Right? And therefore it is 6 is the LCM. So it is 1 minus 2. So it is minus 1 upon 2. Okay. So the value of integration is minus 1 upon 12. Now see that this is the integration value that we have obtained. The same value you will obtain if you put your pen like this and traverse the area. So you are doing the integration with respect to x or with respect to y, depends on how you are traversing this area. Okay, keeping your pen parallel to y-axis and moving like this, or keeping your pen parallel to x-axis and moving like this. Are you getting this? Okay, so I think just go through this. Previous example we have taken where we have done first integration with respect to y and then with respect to x. Now in this example we have done integration with respect to x first and then with respect to y. Okay, fine, right? So now try some of the exercises based on this.